Welcome, everyone. It is Kyle Dickinson, your senior security solution architect that focuses on threat detection and incident response. Back to your hearts and minds. But today, we're actually not going to be talking about security. I know you might be saying, Kyle, are you okay? Well, the answer is maybe, but I am very excited because I am back with my friends at NVIDIA. The last time NVIDIA and I spoke together, we were talking about virtual worlds or digital mirrors and throwing cars at walls so they didn't have to actually throw physical cars at walls because that could be costly. But I'm going to go ahead and let my friends introduce themselves and kind of launch what we're going to be talking about today when it comes to the awesomeness that NVIDIA is bringing to the market.
All right, I'll start. I'm Rick. I'm a principal solutions architect here. Traditionally, I cover the media and entertainment space. And as we kind of look at what we're doing going forward, I'm going to be focusing on the challenges faced by our game development community. Louis?
All right, I'll go second and last. Louis Marcoux, I'm based in Montreal. I'm a technical specialist for Omniverse at NVIDIA. And I focus mainly on the game developers, helping them understand USD, Omniverse, how generative AI connects to all of this. So that's kind of my role.
Now, before we kind of get into the weeds, can you tell me what Omniverse is?
Well, Omniverse is a platform that we have built on top of OpenUSD. And if you hear me say USD or OpenUSD, they're the same thing. They went through a name change, and OpenUSD is the new name. But we've built Omniverse on top of USD to allow people to build the production pipeline for 3D content. And it's a center place where people can create and assemble 3D content and build a pipeline around it so that multiple artists using multiple tools can work together. So Rick, maybe you want to add to that?
I think the best thing is just focusing on the fact that it is a platform for application development. There are a lot of things that are, you know, duct taped and shoe gummed, to make a pipeline work. And Omniverse is helping to enable more efficient pipelines, especially when you're looking at these much larger data sets that people are dealing with, higher fidelity visualization, and a desire to work in real time. So what we're doing is, working with the entire community in OpenUSD. We're trying to make this platform as that development conduit, so people have a place to start, a place to go, and a place to tie all their existing applications together.
Now, you kind of mentioned a funny statement of, with pipelines, it's kind of like duct tape and bubble gum and maybe some nuts and bolts. First of all, my mind goes to steampunk, but 3D models aren't small in size and nature. And it sounds like what you're also doing is you're allowing artists to almost use their own tool sets and that they're comfortable with, but you're providing like a way to just allow it for developers, or not developers, but well, I guess we could say game developers, right?
Yep.
Yeah.
Um, you know, ways to work with what they're most comfortable with, but there's like a translation or like a glue, so to speak,
Mhm.
to bring it to a more common point for others to leverage. Am I
Yep.
hearing that
Yeah.
right?
Well, USD stands for Universal Scene Description. So it describes what the scene needs. And the an artist would use, Maya, Blender, Houdini, 3ds Max. They would create 3D models using their own tool, and they need to save it to a format that everybody can understand and share. So once you save into this format, if it's a closed format, you're stuck with an asset that you cannot work with others. Or if you're building a world and it's stuck in one file, then it's very hard to collaborate and work together on this. So what Universal Scene Description does, or OpenUSD, it describes the files that it needs. It describes the layer that it needs to compose the final scene, and everybody can work on their little USD as long as it's USD at the end. Then it can be assembled either to scripting or a game engine or Omniverse or any application that can assemble USD, and it makes it super easy to collaborate and on a single world or single asset by using all these, you know.
The big
Well,
thing is we are all these amazing to learn another method, another application, do something that's already really good at it. So we don't want to do that. We want to tie them together. We want to like turn independent applications into an ecosystem of,
Mhm.
better together.
Yeah. And
That's really
the
cool.
one point that I want, the last one short point is that USD is a composition engine, which means that it composes multiple um, things together into the final product. So
Now, you mentioned also earlier generative AI. Now, that's a very big topic at the moment. You turn the corner, you hear generative AI. You turn around and you hear generative AI. How is generative AI and OpenUSD kind of working together?
Well, I think you look at Omniverse itself as a platform, the idea is we needed it for ourselves. We have so much research and so much engineering going on. We needed a way to tie our work back together. We're doing graphics focused, um, artificial intelligence, building these networks. We want to apply them in a workspace that our artists can utilize. So for us, we use it like everybody else. We use Omniverse as that development environment so that we can have, if we have something that's going to generate an image that can be used as a texture or a new model that can be used as a background prop, well, we need to utilize it in something. And so we have the perfect development environment for that.
That's awesome. Now, there was one thing, when we were talking backstage, so to speak, audio Two Face, and I immediately think of, the character Two Face. But what does audio Two Face, or is it audio to face, bring to game developers?
well, essentially, it's part of the Omniverse ecosystem. And like we said, we're creating with USD 3D worlds, and inside of 3D worlds, you'll have characters, and those character needs to be animated. And so you'll have animators using a rig in their content creation software. They'll create the animation, but you can also now see some generative AI been brought in to be able to create animation, and that's what Audio to Face does. Audio to Face listens to an audio track, an audio file, and and uses a neural network to understand how the face should be moving to produce these sounds, and then it produces lip sync and emotion, everything that kind of mimics as close as possible what the face would be doing. So what we do in Audio to Face is we generate the facial animation, and then after that you can decide how you're going to use it, either on back into an animation system to tweak it, or to an engine, or even stream into an engine and do some real-time interaction with digital avatars.
So, as you were saying, it takes an audio track and makes the mouth move. I immediately thought, like, if I were to send an audio track of me just screaming at the top of my lungs, but then the animation is just, a mouth open making this loud noise. But then you followed it up with it also generates the emotion. So then you'd see my forehead crunched, or, maybe me going, ah. So, how is that being created by generative AI?
Yes. So the model is trained to understand what your face needs to do to produce the sound that it hears. So that's kind of how the model has been trained. And of course, as we move forward, we continue to improve the model with different languages and different sounds, and even sounds that are not associated to language. So all these things, you need to train the model so that it can understand how to reproduce the facial animation. So
And
That's
then it
that's
it
really
is a
cool.
collection of things because there's a separate network that actually does the emotion. So we can go in and we can tune it. So it's not just kind of like, you hit a button and you have no control over it. The idea is to make it an artist tool so that there are controls in it so you can, work on the intensity of particular focus on things, but also like with the emotion, you can like dial in your own emotion or you can detect the emotion that's coming in from it. So um,
That's really unique. And so not only is it going to help them create the emotion, they can tune it to like their imagination. One of the things that I always think of is when I try to like paint a picture or draw a drawing, I'm always like, how come I can't get my thought on the paper? Now, if I were to have my thought put on the paper already and I'm able to tune it the way that I wanted it to look, then I'd probably be a better artist than I am. But stick figures are my bread and butter still. Um,
Yeah. Like we can't
now,
get eye direction out of your voice, right? So just simple things like that, like how frequently you're going to blink and saccadic motions of your eyes and things like that. And those funny faces that you make, when you're not talking, So all those things, the idea is to not remove the controllability that an animator has, but to provide that initial pass of the lip sync.
yeah. Same thing for irony. If you're being serious and you're being, if you try to make a joke, or if your face is, so all these things are not perceived by the AI. But yeah, but you can still tune the emotions if you want to. But if the emotion or the sound is not in the audio, then the model doesn't know how to react to that.
And so, everyone that has watched AWS On Air and those that have talked with me, they know I'm a very visual person and I love to see cool stuff too. And I understand that both of you have some really cool things to show me. And Lewis, we'll start with you.
Yep.
You were going to go ahead and show us, and I believe it was the audio two face along with like the levers and knobs and stuff that you can use to, make that, customization of emotion. Is that correct?
Yep. Well, if you see my screen now, I'll show you. This is
I will
audio to
bring it
face.
up. Bam.
Okay.
There we go.
So this is audio to face. This is an alien character that we brought in through
We do
USD.
exist.
Yeah. And so this is the character. This is a 3D. And here I've got a sound file, and I can switch from. I've got a couple. I can go live as well if I want to. So if I go here and I go in live mode, it's gonna react to the sound of my voice, and it's gonna mimic the way that I talk. And if you want to, in game production, that's not how it would be used. In game production, people would write dialogues, then they would have an actor recording, or they would use the text to speech tools to generate audio, and then they would bring in here, and they would generate the animation out of this. So when you have an audio file like this,
I am very happy to be here. I hope you enjoy the discussions with my NVIDIA friends. They told me they know their stuff.
so it's just listening to the voice, and I've got another one here, and easily you can say, I want to generate the emotions at the same time. So
I come from a planet far, far away from here. If you watch the sky at night, assuming it's not cloudy, of course, you can see it. When I am back home, I can wave at you so you know where I live.
So as you see, it kind of tries to create emotion. We have the list of emotions here. And sometimes if you want to increase some emotions, so if you want to increase fear, you'll increase the fear here. You can create some keyframes over the track. But if you're doing any type of live streaming, if you're doing it all in real time, then the emotion will be in auto detect on the audio, and it would produce the animation. And we have different means of extracting this. So in audio to face, you can see it here, but the goal is to extract the data, the animation data, and send it to a game engine, or to where the avatar will be rendered in the end. And that's what we've done for some of the project that we've done. I'm going to bring back the screen here so I can see you. So that's kind of an overview of the flow of audio to face. So that's AI creating animation that can be used in a bigger context.
Yeah, it's got like
That's
the
really
two
cool.
different purposes. You could use it for more cinematic content where you're generating keys, which could then be, edited by an artist, or you can stream it directly. And part of what we've been doing is, if you look at the original implementation, it was a standalone application. So now we're looking at how can we take these component pieces? How can we take the neural network that was in the audio to face app and make it so that it's, a standalone microservice that we can then run on its own and say directly take audio input, stream it over a network into an application like the Unreal Engine.
Yeah.
Now,
I have a small slide that I can
Yeah.
show you. Oh well, I'll let you ask your question first.
yeah, no, and yeah, so go ahead and we'll close that out because I know Rick brought a friend of his that's going to make an appearance very shortly. But let's go ahead and you said you had a
Yeah.
slide up here, and it is showing and displaying.
Yeah, so essentially, what I've just shown you is audio to face. You take an audio input, you run it through a deep neural net, you generate the facial animation, then any character can be used to generate animation, and then you can send your animation out to any character. You can batch this, and we have a REST API so that it can be run on the cloud, and you can batch processes and get your data back. Where it's becoming interesting, that's one AI system that generates the animation. When you combine it with other AI system or neural network, you can do some pretty crazy things. So if you think about audio to face, if you have a character in your game that you want to have respond to the player, so you have the player saying, "Hey, how are you? What you're doing?" Then what we can do is mix it with other AIs. Like if you have a speech to text that takes your voice and it's advanced enough to understand the language of the game and some of the lingo of the game and the lore of the game, then it can create pretty meaningful text that can be fed then as an input to a large language model. In our case, we have NeMo, which is the NVIDIA large language model. It generates a response, and then again we have tools like text to speech, Riva in our case, so that generates a voice. That voice gets fed into audio to face, and the character will respond. So what you have at both ends is that you have the player talking and the character is responding. Everything else happens on the cloud. All the AIs are running on the cloud, and what the engine gets back is animation data and the audio to playback, and all of that is pretty fast. So I'll let you look at the video. We've done this demo at Computex. We called the code name was Kairos, but it's essentially in Unreal where we put all these AIs together to have a character interaction. So you want me to play it, or?
Yeah, let's go ahead and have a whirl.
And with we did this project with
We are
Convey.
thrilled to showcase an immersive and dynamic interaction between a player Kai and a non-playable character named Jin. This captivating ramen shop scene was created by NVIDIA using the latest RTX rendering technologies.
Reminds me of Blade
NVIDIA
Runner.
collaborated with Convey, an NVIDIA Inception partner, to showcase how developers will soon be able to use NVIDIA Riva, NeMo,
Such
and
a beautiful
Audio to
environment,
Face
and
for
then we're going to
AI-powered
concentrate on the
speech,
character.
conversation, and animation. These models were integrated into the Convey Services platform and fed into Unreal Engine 5 and MetaHuman to bring Jin to life. Please take a look.
Hey, Jen. How are you?
Unfortunately, not so good.
How come?
I'm worried about the crime around here. It's gotten bad lately. My ramen shop got caught in the crossfire.
Can I help?
If you want to do something about this, I have heard rumors that the powerful crime lord Kuman Aoki is causing all sorts of chaos in the city. He may be the root of this violence.
I'll talk to him. Where can I find him?
I have heard he hangs out in the underground fight clubs on the city's east side. Try there.
Okay, I'll go.
Be careful, Kai.
That's
For me, the
awesome.
impressive thing is that, while you could do this with video editing and trickery, it all works. And,
Yeah.
you will get different responses each time that you approach it because the neural network, based on random seeds and other information about it, time of day, what is happening with the lore in the background. It's a fantastic way of, bringing life to those characters that previously did not have any.
That's gonna take like RPGs, role playing games to a whole new level, and then just more immersive interaction. That is really cool. As a former as a avid fan of video games and especially like role playing games, that's next level.
I
That's
think
really neat.
I think one of the neat things also is you can get a different experience every time you play it, and you can essentially ship new quests without shipping new quests. You could basically, pop it in as an update to the neural network that's running on your cloud, and now everyone's going to see that. So you can have an event that affects the entire population of an open world, and people will find out about it through their interactions with these characters. I mean, it's going to have some pretty groundbreaking effects on the industry.
Well, I we could talk for hours about this because this is, a really awesome topic. But Randy, I know you wanted to bring up another announcement that's coming at SIGGRAPH. Did I say that right?
Well, there's a bunch of SIGGRAPH announcements, and I'm gonna have a friend of mine. He's gonna jump on board, and he's gonna kind of read off our SIGGRAPH announcements. So we there's a lot of stuff that we're doing around RTX. So there's going to be some updates around our professional GPUs and the stuff that we're utilizing to accelerate, the development of game pipelines and pretty much any visual effects or hardcore graphics pipeline. And there's a bunch of stuff around Omniverse and OpenUSD. We've got over 23 papers being presented from our NVIDIA research. Some really great stuff around neural rendering, neural materials, neural texture compression, bunch of stuff around generative AI. And we'll be talking about ACE and ACE for games. But I think the big things we want to highlight is our CEO, Jensen's going to be giving a big keynote on Tuesday at 8 a.m., which might sound early for some people, but it's not early for us. So we really hope people will get there. It'll be streamed, but also, like seeing Jensen live is an experience. I mean, he is a force of nature. Well worth the time if you can make it down there. Um, and as far as I want to talk about, what you're seeing here, I'm basically showing you the other side to ACE. So we talk about how we took audio to face, and we took that neural network from the embedded application and made it a microservice. We can also do it from web cameras driving 2D imagery. So the other part of ACE is what we call live portrait. And in this use case, I just have my tofu. Ha. And Rick, it's Rick, not Randy. But we generated this avatar of an alien. We thought it was kind of fitting, and it's generically trained on a whole bunch of data, and so you don't need to custom train it for new characters. You can just provide it a new image, and then you can have this, webcam drive the avatar. And when we look at, there's two things within a video game. You have the interaction of your player character, of your non-player characters, but there's also how can you drive your player character. Like we have these NPCs that are walking around and talking, but if I turn and I look at Louis in the game and his character is not talking or anything, or I want to have a different persona for him, we can do things like this. Like maybe you have separate chats, and your separate chats you can have these avatars that are generated, or I think tons of applications. And it's a different inferencing thing. We also look at this for localization. So it's really easy to create multiple avatars and have them for different markets.
So if someone wanted to learn more about OpenUSD or try OV and audio to face, where could they start?
We have a download page for Omniverse. That's a great place to start. So it's I have a blank on the exact address, but
We'll include it somewhere in
exactly
the chat, like right here, or it might be over here somewhere.
Perfect. I have it in my notes here, but essentially you go there, you can download, and from there there's a ton of tutorials on USD, even fundamentals one to understand what it is, more technical ones if you want to really go into the deep understanding of USD, and then Omniverse and all of these AIs that we're trying to bring to the Omniverse world.
That's
Yeah,
awesome.
if you go to developer.nvidia.com,
Mhm.
that's a good starting point where you can look at a lot of our SDKs. Like you can get to audio to face in two different ways. You can get to it through Omniverse and through the ACE microservice. Same thing with live portrait. So live portrait is available to the ACE microservice, but it's also available in Maxine as an SDK. So if you wanted to create an application that's running locally and using your local resources, you can do it through Maxine. And that's our SDK that has a lot of features that have been in our broadcast engine. So like audio filtering for noise filtering and super resolution on video. So it's a great collection of SDKs for just overall awesome.
Awesome. Well, hey, it was a pleasure to talk to you both. I learned a lot, and I wish we could continue to talking more, but time is a scarce resource, as they say, unfortunately. But Tofu, Rick, Louis, it was a pleasure. Also, I named your avatar Tofu.
I know that might stick. So we'll see what happens.
I was like, what's the name? So anyway, Tofu.
Yeah.
So it was a pleasure chatting with you too, and I'm looking forward to learning a lot more. Thank you again.
Good.
Thanks for the time, Kyle.
It was fun.
Bye.